So many people want to live as long as possible. They want longevity so badly that they put their bodies through insane regimens of extremely intense diet and exercise that's scheduled down to the minute each and every day. Or they take a bazillion supplements and vitamins that are making wellness industry folks extremely rich. And all of these fads have just had a really shaky underlying evidence base for the whole time that they've been a thing. But now, we have new evidence that tells us that the number of years you live might just be completely out of your control anyway. And this is another thing that's very sad for people to hear. For me, it's kind of cool because we're finding out the exact things to target in order to really genuinely someday increase the human lifespan. But yeah, your third yoga nidra of the day and your sawdust pills aren't gonna do that for you. And this is not to say that there aren't factors within your control, because there absolutely are. There are definitely things you can do and to cultivate that'll make it more likely that you'll live a longer, healthier life. But overall, we just keep finding out more and more that your lifespan and your health span are really just determined by your genes. A person's health span is defined as the number of years they live without serious chronic health conditions or cognitive decline. And it's a term that we've been seeing in the research more and more because a lot of really fatal or debilitating conditions and diseases are becoming survivable chronic issues that people are living with as they live longer as a whole. Of course, there are caveats to that, like the fact that the data is showing us that the millennial generation might be the first in modern history to actually live fewer years than our parents. Brand new research from the Weizmann Institute of Science that was just published in the journal Science uncovered the fact that over 50% of what determines the number of years that you'll live is just genetics. For years and years and years, I think people have tried to really just run away from this fact, and you'll see a lot of the debates in the nature versus nurture discussions of longevity that will insist that genetic factors are very low determinants of one's lifespan, and you just have to sleep better, or eat better, or drink the blood of children like Bryan Johnson does, and then you'll be immortal. It's kind of hard for me to believe that this wasn't attempted before, but what the Weizmann study did was just adjust for all the extrinsic mortality, or the deaths that occur for reasons outside of your own body's systems, like accidents or infections or murder. Extrinsic mortality is a factor that increases as someone gets older because they become more frail and more susceptible to external causes of death. And what the study seems to tell us also is that it was necessary to use some data modeling because the available resources weren't always complete. Like in the case of older data, you had two problems. One was that death records wouldn't always be clear about the cause of death, and you also had the issue that medical technology was progressing at a rapid rate, so it was becoming more useful over time, and therefore lifespans increased accordingly. And all of that is the extrinsic data. The team used data from a century of Scandinavian twin studies, and also a data set from siblings of centenarians in the United States. And when they eliminated the extrinsic factors, they found that genes were way more important than previously thought. And the numbers shot up to someone's genetic makeup, determining 50% of the variability of their lifespan, which is just way more than we previously thought. Before now, the findings had kind of a range between 6% up to 33%. And another correction the team made was that they also had to determine a cutoff age for measuring data sets, because they made a determination that many of the historical deaths at early ages were due to extrinsic factors, at least until modern medicine changed that around. A lot of infant mortality, for example, happened because we didn't have great disease-preventing technology. Once again, I find this pretty astounding, but the team has said that, to their knowledge, nobody else has ever studied longevity by eliminating extrinsic mortality and establishing a cutoff age to filter out things like extrinsic infant mortality. Super bonkers, actually. And it lets us see just how much genes play a role in this. Like in the case of American centenarians, or people living in America who made it to the age of 100 or beyond, their siblings had a much greater chance of then also reaching the age of 100 themselves, and that lines up with the findings overall. And 20% of centenarians reached the age of 100 without suffering from serious health conditions. And this raises the idea that it's possible that not only are certain genes life extenders, but those specific genes might also have a particularly protective element to them too. And we know about some of these genes. We have a lot of information about specific pathways with specific diseases and conditions. And here and there, we also have knowledge of certain genes that simply seem to be associated with longer lifespans in general. We know that telomeres, or the DNA structures that cap off the ends of our chromosomes, it very much appears that those of us with longer telomeres happen to live longer, because they tend to get shorter and shorter as the cells divide until they can't divide anymore and the cells start to die. We also know that there are genes that function to perform telomere maintenance. There are also genes that reduce inflammation throughout the body, and inflammation has been continuously associated with pretty much every pathology known to humankind at this point. I remember learning about the p53 gene in high school, which is a gene that protects against abnormal cell growth and triggers cell death before cancerous growths can take hold. And if that malfunctions, then things can get bad. This is why none of this really surprises me at all. And I'm also very okay with it. I personally have always just assumed that the building blocks of our meat computers would be the things that determine how the programming works. And we were starting to see this quite a bit in the research into diseases like cancer and even mental illness. And it's not altogether clear-cut, of course, because even if you have very well-known cancer-associated genes like BRCA, or you have something like a p53 malfunction, you aren't guaranteed to ever be diagnosed with cancer. And all that is something that the field of epigenetics continues to work on. Epigenetics being the idea that while genes are static, gene expression can be altered and caused to be silent or activated or just different somehow, and that these changes can also be hereditary. Some external factor might cause a particular gene expression to change and become a malignant force, or someone else with the same genetic makeup could go their whole lives and see completely different results because of their own specific environmental factors. Just for example, p53 is known to be malfunctioning in about 50% of all cancers, but that still leaves a whole half of mystery left to solve, because what is all the rest of that other 50%? And does that mean that people can do things like smoke their entire lives, and if their p53 genes are firing just right, then they'll never get lung cancer? Even though smoking is a definite cause of lung cancer and probably one of the most imminent predictors that you're gonna get it. And now that we're in a situation that we can probably say that lifespan is about 50-50 genetics and environment, then that really tracks with the kinds of things that we're seeing in other research about human health too. And the ways that this interplays between genes and external factors that cause gene expression to manifest in different ways could really be the actual answer to figuring out the big questions about human health. And the question that I think this answers right now is that you don't have to live like Bryan Johnson. He's going to die. And whatever insane and untested craziness that he's putting himself through every day instead of living his life is probably not going to help him. The thing about science and research is that it's constantly evolving, and he could be doing things to himself right now in search of immortality that are actually tearing apart some unknown mechanism in the body that's actually going to shorten his lifespan. This is just like why your grandma lived to be a bazillion doing all the exact wrong things, and why people like this guy are just statistically probably going to have pretty normal lifespans, even with all that work they put in. So, go outside. Have fun. Don't worry about things that you can't control. And if you're too worried about it, in the sense that it's becoming pathological and interfering with your life, like it actually is with Bryan Johnson, do some work in the realm of your mental health. Because discovering things that you can't control, and then controlling how you feel about them, and changing the narrative in your own head, is one of the underlying mechanisms of, going to therapy. Instead of giving your years away to a compulsion that will very likely yield you no results, try to just make peace with it. Even if it does get you some negligible amount of days extending your lifespan, you could also just get hit by a bus tomorrow, or eaten by a roving band of koalas. We just don't know. But definitely don't go off the deep end and give grifters lots of money for supplements and nonsense treatments. Instead, think about living more intentionally and experiencing what you want to experience. And that because the meaning of life in this context is really just what you yourself make it, then try to do some good in your own little sphere of influence in the world. That's what I'm doing, and that's what this whole channel's about, and that's what we should all be doing. And then it won't matter how long you're here, because we'll be here for a good time, not a long time. And the legacy of your vital work toward human happiness and social connection and goodwill will last into the farthest reaches of our species. I'll see you there, where our descendants are still playing my videos somewhere in the Andromeda galaxy, wondering what we did all the way back here in the past with such short and shitty lives. I'll see you next time.